Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 6 Probability. Topic Multiplication Theorem on Probability. Independent Events. Exercise 13.2. Multiplication Theorem on Probability. P of E intersection F is equal to P of E into P of F by E, and P of E intersection F is also equal to P of F into P of E by F. These two theorems are known as multiplication theorem on probability. Multiplication rule of probability for more than two events. P of E intersection F intersection Z is equal to P of E into P of F by E into P of Z by E intersection F, which can be shortly written as P of E into P of F by E into P of Z by EF. Independent events. When are two events said to be independent events? Two events are independent events if the probability of occurrence of one of them is not affected by occurrence of the other. Or two events are independent events if P of F by E is equal to P of F, provided P of E does not equal to 0. And P of E by F is equal to P of E, provided P of F does not equal to 0. Or if E and F are independent events, then P of E intersection F equal to P of E into P of F. Event ani independent oiba event sing haigani event amagi phangbagi probability na atopa event amagi occurrence ta akaiba pidrabani. Note 1. If A, B, and C are independent events, then P of A intersection B intersection C is equal to P of A into P of B into P of C. If E and F are not independent events, then P of E intersection F does not equal to P of E into P of F. Two events cannot be independent and mutually exclusive simultaneously. Event ani independent su oiba mutually exclusive su oiba matam amatada oiba yade. Ama oirabadi amadu oiroi. The term independent is defined in terms of probability of events, whereas mutually exclusive is defined in terms of events. Mutually exclusive hairagana events singda nainabani, aduga independent event hairagana events singi probability singda nainabani. Mutually exclusive events never have an outcome common, but independent events may have common outcome. Mutually exclusive oiba events singidi common outcome sunglai leite, adubu independent events singidi common outcome leiba yai. Prove that if the events E and F are independent, 1. Not E and F are independent, Roman number 2. E and not F are independent, Roman number 3. Not E and not F are independent events. E amasung F si independent events oirabadi, not E ga F ka independent event oigani prove tau, E ga not F ka independent event oigani prove tau, not issue not F animak independent event oigani prove tau. Let us prove. Here E and F are independent events, so P of E intersection F equal to P of E into P of F. Roman number 1. P of not E intersection F is equal to P of F minus P of E intersection F. Remember this statement. And P of E intersection F, which is equal to P of E into P of F by given condition, and taking common factors, that is P of F, from two terms we get 1 minus P of E times of P of F, 1 minus P of E is equal to P of not E and into P of F. Therefore, P of E not E intersection F equal to P of not E into P of F if these conditions are arrived. Thus, the events not E and F are independent events. Roman number 2, similar to Roman number 1. For Roman number 3, P of not E intersection not F is equal to P of not E union F by this property, complementation law on sets, and which is equal to 1 minus P of E union F according to this rule. And the P of E union F can be expanded in these three terms, and expanding we get this, taking combine the first two terms we get this, and taking minus P of F from the last two terms we get minus P of F into 1 minus P of E. Again, these two terms we have to take 1 minus P of E. For first term remains 1, for second term minus P F. These two products are equal to, the first one is P of not E and the second one is P of not F. Thus, P of not E intersection not F is equal to P of not E into P of not F. This shows that the events not E and not F are independent events. Exercise 13.2. Question number 1. If probability of happening of A is 3 by 5 and probability of happening of B is 1 by 5, these two quantities are given. Find P of A intersection B if A and B are independent events. We are also given A and B are independent. So we have to find out P of A intersection B. Here P of A is 3 by 5, P of B is 1 by 5, A and B are independent events. Therefore, P of A intersection B by given conditions, we have P of A into P of B. Their respective values are put and multiply, we get 3 by 25, which is the required probability. Question number 2. Two cards are drawn at random and without replacement from a pack of 52 playing cards. Find the probability that both the cards are played. We have to draw two cards from 52 cards one by one without replacement. Let A denotes the event of drawing a black card in the first row and B the event of drawing a black card in second row. A is the event of drawing a black card in the first row. After this, we have B stand for the event of drawing a black card in the second row. Then P of A. There are 26 black cards out of 52 cards. Therefore, probability of drawing a black card from 52 is 26 by 52. And the P of B by A. That means after the first black card is drawn, we are left with 52 cards, of which 25 are black cards. Therefore, this is the probability of drawing a black card in the second row, given that one black card has already drawn. That is 25 by 51. Therefore, required probability is given by P of A intersection B. Find the probability that both the cards are black. The required probability is equal to probability of A intersection B, which is again equal to P of A into P of B by A. Their respective values are put and we simplify, we get 25 by 102, which is the required probability. Question number 3. A box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. Box amad orange yauba box amadagi box orange ahumkhak randomly amamam laukhatlaga hapsin the video yengi. If all the 3 oranges are good, the box is approved for sale. Adom na laukhatpa asum na laukhatpa orange ahummak afaba ngakta oirabadi madugi box ado yonanabagi approve towi. Otherwise, it is rejected. Haribo unosi event se toktrabadi reject towi yonba yade. Find the probability that a box containing 15 oranges, out of which 12 are good and 3 are bad ones, will be approved for sale. asumna orange tanga yauba afabana 12 fatabana ahum yauba box amadagi hariba box adu yonba yagani haibagi probability putu u haiben. Let A, B, C be the events of drawing good oranges in the first, second, and third draws respectively. Then P of A ahanba 15 yaubani 12 ni afabadi madugi manungda ahanbada good orange ama lokotpagi probability di 12 by 15 ni. Hojik 15 orange tagi afaba ama loktokrabadi 14 oranges lehori madugi manungda afaba 12 tagi afaba ama lokotkrabadi afaba taramatu lehori. That P of B by A is 11 by 14. Afaba ani lokotkraba matungda ball 13 lehori afabana tara lehori. Therefore P of C by AB is 10 by 13. Therefore require probability haibadi ball ahumak afaba orabadi approve for cell ne ahumak afaba oigani haibagi probability di P of A intersection B intersection C na pigani, which is again equal to P of A into P of B by A into P of C by AB. Their respective values are put and simplify, we get 44 by 91, which is the required probability. For question number 4, a pair coil and an unbiased die are tossed. Coil amaga die amaga punna tossed away. Let A be the event head appears on the coil. A na coil die head pangbabu head ubabu pangbabu A na khanarasi, and B be the event 3 on the die the 3 pangbabu B na khanarasi. Check whether A and B are independent events or not. A amasung B is independent events sing oibra check to haibani. We have P of A is what probability of getting a head when a pair coil is tossed, that is half, and P of B, which is what, this is the probability of getting 3 when a die is rolled, that is 1 by 6. Also, as the sample space for this event is ICE1, ICE2, ICE3, ICE4, ICE5, ICE6, T1, T2, T3, T4, T5, T6, of which A consists of ICE1, ICE2, ICE3, ICE4, ICE5, ICE6. A di coil na head phangbani, head phangakandadi die dunadi mawung taruk ta thokpa yai asuma taruk lani. B haibasidadi head phangba matamda matang die the 3 phangbani adudi ICE3 T3 oirani. Anigi intersection di A intersection B di ICE3 na oirani. Therefore, P of A intersection B D 1 later out of 12 ki manung 1 and which is equal to P of A into P of B, that is 1 by 2 into 1 by 6, that is 1 by 12. P of A intersection whose value is equal to P of A into P of B. Hence, the two events are independent events. Hence, A and B are independent events. For question number 5, a die mark 1, 2, 3 in red and 4, 5, 6 in green is tossed. Die ludo amada 1, 2, 3 na red na E, 4, 5, 6 na green na E. Tossed away. Let A be the event the number is even and B be the event the number is red. Are A and B independent? A asina even number pangbagi event ni, B asina red number ama pangbagi event ni. The number is even. A na even number pangbagi, B na red number ama pangbagi event ni. A ga B ga independent oibra hangmani. We have A consists of 2, 4, 6, B consists of red number D 1, 2, 3 ni. And A intersection B common element T2 lady and S consists of 1, 2, 3, 4, 5, 6. Therefore, P of A is out of 6 kimanung the 3 letter 3 by 6. P of B out of 6 kimanung the 3 letter 3 by 6. P of A intersection BD, A intersection BD 1 by 6. Now P of A into P of B, their values are multiplied and we get 1 by 4, which does not equal to the value of P of A intersection B, that is 1 by 6. Manadre. Thus A and B are not independent events. Mabani independent events in order. Question number 6. Let E and F be events such that P of E is 3 by 5, P of F is 3 by 10, and P of E intersection F is 1 by 5. Are E and F independent? Here these values are given. We have P of E into P of F, that is 3 by 5 into 3 by 10, we get 9 by 50, which does not equal to the value of P of E intersection F, that is 1 by 5. 9 by 50 का 1 by 5 का मानद्रबनिना P of E into P of F की product का P of E intersection F का मानद्रे. Therefore, E and F are not independent events. For question number 7, given that the events A and B are such that P of A is half P of A union B is 3 by 5 and P of B is small p, find P if they are mutually exclusive independent. For here these values are given. If A and B are mutually exclusive events, then P of A union B is equal to P of A plus P of B. For mutually exclusive events, P of A union B is equal to P of A plus P of B. Putting their respective values, we get this. Solving P, we get 1 by 10. For Roman number 2, if A and B are independent events, we have P of A union B equal to P of A plus P of B minus P of A intersection B. And put 3 by 5 for this, 1 by 2 for this B. P. For this, we have to express P of A into P of B. Again, put P of B is small p, P of A is 1 by 2. Solving this 2, we get P by 2. Solving, lastly, we get P is 1 by 5. For when the two events are independent, P would be 1 by 5. And when A and B are mutually exclusive events, P should be 1 by 10. Question number 8. Let A and B be events such that P of A is 0.3 and P of B is 0.4. Find P of A intersection B, A union B, A by B, B by A. Let us find out. P of A intersection B is equal to P of A into P of B, as the two events are independent events. And put their values are 0.3 into 0.4. Their product is 0.12. For Roman number 2, we have P of A union B is equal to P of A plus P of B minus P of A intersection B. Put their values. P of A is 0.43, P of B is 0.4, P of A intersection B is 0.12. Subtracting, we get 0.58. For Roman number 3, P of A by B is equal to P of A intersection B by P of B. Put their respective values, we get 0.3. Roman number 4, P of B by A is equal to P of A intersection B by P of A. Put their respective values, we get this, which is also 0.4. These are the required values of the probabilities. Question number 9. If A and B are two events such that P of A is 1 by 4, P of B is half, and P of A intersection B is 1 by 8, find P of not A and not B. These values are given. P of not A and not B is in symbol. We have P of not A intersection not B, and which is equal to P of not A union B. Again, which is equal to 1 minus P of A union B. P of A union B can be expanded this. And put their respective values. P of A is 1 by 4, P of B is 1 by 8, P of A intersection B is given as 1 by 8. And solve, we get 3 by 8, which is the required probability. For question number 10, events A and B are such that P of A is half, P of B is 7 by 12, and P of not A or not B is 1 by 4. State whether A and B are independent. Here these values are given. P of not A or union not B is symbolically we have this. And using De Morgan's law, we get which can be written as A intersection B complement, and which is 1 minus P of A intersection B, whose value is 3 by 4. Again, also the product of P of A and P of B is 1 by 2 into 7 by 12, which is 7 by 24. These two values are not equal. Thus, P of A intersection B does not equal to product of P of A and P of B. This shows that A and B are not independent events. For question number 11, given two independent events A and B such that P of A is 0.3, P of B is 0.6. Find P of A and B, P of A and not B, P of A or B, P of neither A nor B. Let us find out. A and B are independent events. Also, P of A is given as 0.3, P of B is also 0.6. Roman number 1, P of A and B in symbol P of A intersection B, which can be expressed as P of A into P of B, as A and B are independent events, and put their values, we get 0.818. For Roman number 2, P of A and not B, which in symbol P of A intersection B complement, which is equal to P of A minus P of A intersection B. P of A is 0.3 and P of A intersection B is thus found out 0.18. Subtracting, we get 0.12. For Roman number 3, P of A or B, which is in symbol P of A union B, and expanded, we get this, put their respective values, and we get 0.72. For Roman number 4, P of neither A nor B is in symbol P of not A intersection not B, and which is equal to P of A union B not of A union B, and 1 minus P of A union B. P of A union B is already found out, whose value is 0.72. 0.72. Subtracting, we get 0.28. For question number 12, a die is tossed thrice. Find the probability of getting an odd number at least once. Ludo ama ahumlak huli yamdrabada odd number ama phambagi probability pudu. There are 3 odd numbers when a dice is rolled. Probability of getting an probability of getting even numbers when the dice is rolled thrice. 1 by 2 into 1 by 2 into 1 by 2, we get 1 by 8. Therefore, probability of getting at least one odd number, that is 1 minus 1 by 8, that is 7 by 8. Question number 13. 2 balls are drawn at random with replacement from a box containing 10 black and 8 red balls. Find the probability that both balls are red. First ball is black and second is red. One of them is black and other is red. 2 balls are drawn at random with replacement from a box containing 10 black and 8 red balls. Total balls 10 plus 8, 18 ni. Probability of both balls are red. 18 to the taran red, nipan red ni. Ahan was red local, anis red local, that is 8 by 18 into 8 by 18. That gives 16 by 81. First bone is black and second is red. Probability of first bone black and second red is 10 by 18 into 8 by 18, that is 20 by 81. For Roman number 3, probability of 1 black and 1 red, that is red, black, red, black, red, that is taken in this, it may be taken in this order, 10 by 18 into 8 by 18, plus probability of first red, second black, that is red, black, red, black, red, 8 by 18, black is 10 by 18. We have two mutually outcomes, black, red, red, black, and sum up we get 40 by 81. Question number 14. Probability of solving specific problem independently by A and B are half and 1 by 3 respectively. If both try to solve the problem independently, find the probability that the problem is solved. Exactly one of them solves the problem. Their respective probabilities of solving are 1 by 2 and 1 by 3. These two values are given. If both try to solve the problem independently, find the probability that the problem is solved. We have P of A is half and P of B is 1 by 3. The problem is solved if at least one of them solves the problem. makoi anigi manungdagi yamdrabada amana solve tawrabadi problem adu solve tawba ngami. Therefore require probability di A na solve tawraga B na tawdrabasu B na tawraga A na tawdrabasu animak solve tawrabasu hariba case ahum simaga leire. aduga makoi animana solve tawba ngamdaba case leire. Makoi event mutually exclusive oiba event mari sidagi makoi animak na solve tawba ngamdaba probability ase khaidokrabadi 1 dagi lemoriba singdo A na solve tawraga B na tawdaba B na tawraga A na tawdaba animak na tawba case ahum do phangi whose value is this maran independent event singorabanina independently harabanina product of phongdoni P of not AD 1 minus P of N. P gani P of not B is equal to 1 minus P of B. Put their respective values half and 1 by 3 respectively and solving we get 2 by 3. For Roman number 2, exactly one of them solves the problem. Exactly one of them solves the problem, which means A solved, B not solved. When B solved, A not solved. This is exactly one of them solves the problem. There are two mutually exclusive events. Required probability is probability that not A B, or A not B. We have these two mutually exclusive events, and their probability is probability of first one plus probability of second event. And these are also independent. We have to express P of not A into P of B plus, which is also express product of P of A into P of not B. Put their respective values and solve, we get half. For question number 15, one card is drawn at random from a well-shuffled deck of 52 cards. In which of the following cases are the events E and F independent? E. The card drawn is a spade. F. The card drawn is an A. Therefore, E consists of P of E. Probability of drawing a spade. Spade is 13 out of 52. We get 1 by 4. Probability of drawing a card drawn is an A. The card drawn is an A. There are 4 A's in 52 whose probability is 1 by 13. And spade with A. What does it mean? E intersection the A of spade, which is only 1. Therefore, its probability is 1 by 52. Now, P of E intersection F equal to P of E into P of F implies E and F are independent events. For Roman number 2, the card drawn is black, that is P of E is 26 by 52 and we get half. P of F, the card drawn is a king. There are 4 kings in 52 cards, which is 1 by 13. And P of E intersection F, what does it mean? Black with king. Black with king, there are 2 black kings, and whose probability is 2 by 52, 1 by 26. Now P of E into P of F, their product half into 1 by 13 is 1 by 26, which is also the value of P of E intersection F. Implies E and F are independent events. For Roman number 3, the card drawn is a king or queen. A king or queen. Therefore, probability of E is 8 by 52. There are 4 kings and 4 queens. Sum up, we get 8 by 52. That is 2 by 13. P of F means the card drawn is a queen or jack. A queen or jack. There are 4 queens and 4 jacks, whose probability is also 2 by 13. Therefore, P of E intersection F, what does it mean? A king or a queen, or queen or king. Both queen. We have common is queen. Therefore, probability of queen. Drawing a queen is 4 by 52. That is 1 by 13. Now, P of E into P of F, their value is 2 by 13 into 2 by 13. That is 4 by 169, which does not equal to the value of P intersection F, that is 1 by 13. Therefore, E and F are not independent events. For question number 16, in a hostel, 60% of the students read Hindi newspaper, 40% read English newspaper, and 20% read both Hindi and English newspapers. A student is selected at random Find the probability that she reads neither Hindi nor English newspapers. If she reads Hindi newspaper, find the probability that she reads English newspaper. If she reads English newspaper, find the probability that she reads Hindi newspaper. For first one, find the probability that she reads neither Hindi nor English newspaper. Let Is and E be the events that a student reads Hindi and English respectively. Then P of Is, probability of drawing a student who reads Hindi newspaper is 60%, that is 60 by 100. And the probability of drawing a student who reads English newspaper is 40%, that is 40 by 100. And the probability of drawing a student who reads both is 20 by 100. For first one, probability of not Is and not E. This is in symbol P of Is, not Is intersection not E, and which is equal to P of not E Is union A. Again, which is equal to 1 minus P of Is union A, and whose value is 60 by 100 plus 40 by 100 minus 20 by 100. Simplify, we get 1 by 5, which is the required probability. For B, if she reads Hindi newspaper, find the probability that she reads English newspaper. For this, we have to find out P of E by Is, which is equal to P of Is intersection E by P of Is, whose value is 20 by 100 and whose value is 60 by 100. We get 1 by 3. For C, P of Is by E, which is equal to this, and respective values are this. Solving, we get half. Choose the correct answer in exercises 17 and 18. 17. The probability of obtaining an even prime number on its die when a pair of dice is rolled is. Probability of drawing an even prime on its die is 1 by 36. Animakta even prime over the 2 which is there are 36 outcome. Out of which 2 the only outcome, one outcome is both in both even. Correct answer is D. For 18, two events A and B will be independent if A and B are mutually exclusive. P of not A not B is equal to 1 minus P of A into P of 1 minus P of B. P of A equal to P of B. P of A plus P of B equal to 1. This one is true. A and B are independent event. Independent or the A must be mutually exclusive or P of not A not B as D. As in option B as chungani A and B are independent, then not A and not B are independent. Extra questions. These extra questions can be attempted. Thank you for watching video.